Hello everyone, Mr. Fritz here, and in this video excuse me. In this video, we're going to talk about double angle identities. Let's first start off with a little bit of a warm-up, though, about that's going to prep our minds for these double angle identities. So here's a little bit of a throwback. Given the point -6, 8 is on the terminal side of an angle in standard position, find all 6 trig ratios for the angle formed. So this is one of those scenarios where we are going to be positioning on the xy axis where this point actually is. -6, 8 is somewhere around here and is on the terminal side of some angle.
Shade DMOD to the main office, please. Shade DMOD to the main office, please.
Let's call that angle theta. And we want to find the sine of that theta, the cosine, all that stuff. So sine theta, cosine of theta, tan theta, secant theta, cosecant theta, and cotangent of theta. So in order to do that, we need to know what the horizontal, vertical, and hypotenuse distances are. So if you think about this like a right triangle, I have 3 parts of this right triangle. The horizontal distance is given by 6, since that x position or x displacement is -6. The vertical length is 8, since I'm going up 8 to this coordinate. And we need to find this missing hypotenuse, and usually we call that r. So the r is going to be given by x squared, we're using Pythagorean theorem, plus y squared equals r squared. So that's going to be 8 squared plus 6 squared equals r squared. And so it's going to be 64 plus 36 equals r squared, or 100 equals r squared. So that means that r is going to equal 10 once I take the square root of both sides. So knowing that, the sine of this angle is going to be equal to the opposite over the hypotenuse, or the y over r. So we can start to just fill things in. I know that x equals -6, y equals 8, r equals 10, and I fill in all of my big 6 trig ratios. So the sine of theta is going to be y over r, so that's 8 over 10, which is equal to 4/5. Cosine of theta is the adjacent over hypotenuse, so it's going to be a -6/10, or -3/5. Tangent will be sine over cosine, so that's -4/3. Secant is the reciprocal of cosine, so that's going to be -5/3. Cosecant is the reciprocal of sine, so that's going to be 5/4. And the cotangent will be the reciprocal of tangent, so that's -3/4. So hopefully that just reminds us a little bit about how we find these other trig ratios, given some information about a terminal side, the point on a terminal side of an angle. We're going to use similar types of skills with this double angle identity. So let's kind of jump right into this. First, I'm going to give you some formulas. These are identities. These are equivalencies. We can use them because they're equal, always. First one is for the sine of 2 times an angle. The sine of 2a is equal to twice the sine of a times the cosine of a. For the cosine, there's 3 options for this one. These are all the same, and hopefully you're seeing that these are actually equal to each other, because think about it, if I were to substitute something in for sine squared, I'll end up getting this second identity right here. So really, if you remember just one of them, you can derive the other 2. What I mean by that, remember sine squared of a, that's going to equal 1 minus the cosine squared of a. So if I just take this whole package and substitute it into this right here, I do in fact get, after a little bit of algebra, the second line. And then I can do the same thing with substituting for cosine of a to get the third line, and so on and so forth. So here are 2 formulas that we are going to use. We're going to be asked to find the sine of 2 times some angle, and we're going to need to use these components of these identities or formulas to actually figure out what those things are. So let's jump right into this. Here's my first example. I'm given the sine of alpha is equal to 3/5, and the cosine of alpha equals -4/5. So I want to find the sine of 2 times alpha and the cosine of 2 times alpha. So let's jump to our equations. Well, the sine of 2 alpha is going to equal 2 times the sine of alpha times the cosine of alpha. This is what I want to find over here, sine of 2 alpha. And so this is what I need over here. Well, it turns out I do have the sine of alpha and the cosine of alpha. So I'm just basically plugging stuff in. The sine of 2 alpha is going to equal 2 times the sine of alpha, which is 3/5, times the cosine of alpha, which is -4/5. And we're just going to multiply this stuff together. So 2 times 3 times -4 is -24 over 5 times 5, which is 25. So the sine of 2 alpha equals negative 24 25ths. Simple as that. Why don't you try an example that's very, very similar to it? I've got 2 examples for you. It's using both the double angle for sine and double angle for cosine formulas. Pause the video, give this one a shot. All right, and here are my solutions with the work provided. In the next video, we'll do another example.